All right.
Writing a number on the quiz?
Yeah. What's up?
Where you go?
Oh, hold on, guys. So first off, Jody had a question from homework. I'll think about it.
The first one is number 36, section 6.2.
All right, guys, take a look. 6.2, number 36. Oh, just. Six two, number 36, right?
Yep.
So if you read through this one, it sounds lovely. I don't think that's the same word you use. But how does this thing look? And in math, I can make ratios of any damn thing I want to. So I can certainly make ratios of fractions, which when I step back is like fractions inside of fractions. You know, and that kind of drives us a little crazy if you're not careful. All I have to do is remember that that big bar in the middle means divide. And I know how to handle fractions with division. So it says, this whole thing is write each sentence as a proportion, then tell me if it's true. So 10 elevenths is to 3/4. So what's on the top here? 10 elevenths, so like 10 over 11. What's on the bottom? 3 over 4. So 10 elevenths is to 3/4 as 1/4 is to 1/2. Sorry, this is number 36. 60. So over here it says as 1/4 is to 1/2. So what's on the top?
1/4.
1/4.
1/2.
1/2. So this is to that as this is to that. So that's what the proportion looks like. That sentence, that English sentence in math. Now how do I tell if it's true? Cross multiply. And if I end up with a true statement, then it must be true. So then, this is where, if you could do this, you're going to get so much further in math and things are going to make so much more sense. If you can just remember, and somebody was telling me earlier that they kind of like it when I say that, or that it sticks in the brain. Math doesn't care what's in there. The process doesn't change just because there are ugly things in there. The process is cross multiply. You don't have to do the multiplication in your head. You just write 10 elevenths times 1/2 equals 1/4 times 3/4. There's nothing that says you have to do in your head and then write the answer down. You just write down what you're supposed to do and then do it next. That will also get you pretty far. And now you just do it. You've written down what you have to do. You can pretty much already tell, maybe. What's the bottom over here going to be? 16. The bottom over here is going to be... They don't really jive, right? But let's see. How do I get... What do I do here?
11. 2 was a 10 factor.
Good. So 5 elevenths. Once you reduce it, it'll be 11. I like it. And this is 3. There's nothing to reduce, so it's 3 over 16. And is that true?
No.
Hell no. Right? And now I can tell. I know. I don't have to do. I could cross multiply one more time. You could. 16 times 5. 80. 11 times 3. 33. No. But I really don't need to. If it's in lowest terms, if it's equal, it must be the same exact ratio when you put them in lowest terms. So right there, I know it's not true. Right? So not true. What's up?
Could you also work out?
Each individual one?
Uh-huh.
Oh, hell yeah.
You could do that.
Oh, hell yeah. So if I do that instead, so if I have 10 elevenths to 3/4 is 1/4 to 1/2. So what Judy's saying is, can't you just work with that fraction by itself? Of course, how the hell would you do that? Probably like I was saying earlier. This is a fraction divided by a fraction. How do you do that? Oops. So that's that divided by this. And that, of course, becomes that times. And what's that? 40 over 33. Let me just stop right there. You guys kind of... This is one way to do it. The problem is done. There's another way to do it if you want to. You don't have to do both. There's another way to do it. You could simplify this side, simplify that side, and see what the hell they are. Are they equal to each other? So you get 40, 33. If you do this division, which is multiplying by the reciprocal, what about over here? It'd be 1/4 divided by a half. So it'll be 1/4 times 2 over 1. It'll be 1/2. Is 40 over 33 equal to 1/2? No, so not true. Thankfully, no matter which way you do it, it comes up to the same answer. It's got to be that way. Is that cool? So in a way, it kind of sucks when there's so many ways to do a math problem, and there's almost always at least 50 ways to do a math problem. And it kind of sucks because sometimes people do half of one way and half of another way or something, and that's where things really get weird. Or students get like really low, when do I do this or when do I do that? Well, you do either one. They both work. Right? So you just do the one that makes more sense, or do the one that you first think of. Is that cool? Okay.
I have more questions
Yes.
on the homework. Number 7 on section 6.4.
Oh.
So I realized I could do that with a calculator, but I'm lost at how to do it by hand.
I like it. So you don't say to use a calculator, don't. You shouldn't need to. And in fact, remind me, what's this here?
13.
Careful.
7.
Why is it 7?
Two.
Because 7 times 7 is 49. Well, that little square root symbol asks you, what does it take 2 of, there's an understood 2 here, to multiply to be this. So that's why we think backwards about roots. Right? So the square root of 49 is 7 because
7 times 7.
7 times 7 is 49. Or even better, 7 squared. Square and square root are the opposite of each other. How we doing, Drew? Is that cool? So now watch this. Let me kind of start on this side. What is what's 2 fifths times 2 fifths? Good. 4 over 25. So what can I write here that kind of captures 7 times 7 is 49, so the square root of 49 is 7. 2 fifths times 2 fifths is 4 25ths. So the... Let's see if you guys can do
2 fifths?
7 times 7 is 49, so the square root of 49 is 7. 2 fifths times 2 is 4 25ths, so the square root of 4 25ths must be 2 fifths, because it takes 2 of these to multiply by this. And look at it better. What's the square root of 4? 2. What's the square root of 25? 5. So when you're faced with something more like, what's this one?
16.
Oh yeah, you'll like this. There's 2 ways really to do this, but what's the square root of 16?
4.
4. Square root of 64? 8. Now let me stop right there. Does everybody see where those numbers are coming from?
Yes.
Because you're thinking backwards. The square root symbol means what does it take to multiply to be this? What? How? 2 of what multiplies to be 16? 2 4s multiply to be 16. 2 8s multiply to be 64. And of course, what's 4 8s?
2 4.
Yeah, 1/2. Cool. Because I don't know if anybody noticed, you could reduce this from the beginning. 16 goes into 64. 4 times. And what's the square root of 1?
1.
1. Because 1 times 1 is 1. What's the square root of 4? 2. So both ways you do it, you get 1/2. Reduce it first or reduce it last. Math doesn't care. Right? You do whichever one's easier.
I have one more.
All right. Nobody's...
33 on section 6.4. That's my last one.
So, what is it that relates A, B, C in this picture? And why do I put C where it is? I specifically put C in a certain place because it has to be there. It's related to 33, section 6.4. First off, what's the theorem that tells me how these guys relate? Pythagorean theorem. I showed you last time the nice visual of the squares hanging off the side, so it's a way to remember the formula. The A squared, there's a square that has a squared area, right? So the A squared plus B squared has to equal to C squared. So it'd be the square off of there, and the square off of there, and the square off of there. If you add those two areas, you'll get that area. It's a really cool way to remember it. Okay, cool. Why did I put C where it is? I love it. And look at the equation. Which one is the biggest numbers? A, B, or C? C, because it's A and B added, right? They're squared too, but you kind of see what I'm saying? So it kind of matches. That's got to be the longest side. Why? Because it's across from the biggest angle. So of course it's going to be the longest side fits in there, right? Big ass alligator, put the stick in there so he doesn't bite your head off. It's going to... So it's got to be the longest side there. So it should be in the equation the one that the other two add to make. If you put the wrong thing in for C, you're going to get a really weird answer. You're going to get what's called an imaginary answer. You don't want to do that. I think it's freaky. So the problem we got specifically on this problem is, which one was it? 33. It says we have, of course they've angled it all weird. Let's see. Which one? Here's my right angle. I say this is 22, 48. So which letter is this? C. Because it's across from the biggest angle. My poor... Sorry, I can't let that go. There you go. All right, now it's semi-straight. Okay. How do I set up the formula then? Careful.
22 squared.
22 squared.
Plus 48 squared. Equals C squared.
No. Double 22 is 44. 22 squared is 22 times 22, right?
That's the 444.
Proportion? Square root?
Yes.
Yeah, we will have to eventually, but not yet. I can't do anything with it yet. In fact,
It doesn't matter with 22 squared and 48 squared, how they line up.
exactly, because I'm adding them. Who cares? So A and B, I don't care which one is which. Because I'm going to end up adding them, and A plus B is the same as B plus A. The most important side, the only real important side is that guy. The longest side has got to be over by itself. The other two sides are adding, so who cares which one you call A, which one you call B. Right? But C has got to be the longest side. So 22 squared is what? 484, I like it. 48 squared.
2304.
Take your word for it. And then I get equals C squared, right? Add them, 11. So what do you get when you add those? 2788. And then, to finish this off, I know that 2788 is C squared, but what do I want? I want C. So how do I undo? So right now I've got this. What's the opposite of squaring something?
Not squaring. Not squaring.
Anti-squaring. Circling it. So the opposite of squaring something is square rooting something. You with me? And again, we can see that. If I square 3, what do I get? 9. If I square root 9, I get 3 back. So the square root undoes what the square did. That's what opposite functions do. So if I take the square root of both sides, what's the square root of c squared? It's just c. It's almost too easy. What does it multiply? What two things multiply to be c squared? Well, c times c. So it's c. Even better, the square root and the square just cancel. Now the other side is what you got to plug in the calculator. What's the square root of 2788? That's not right. What is it now? It's too big.
52.8.
You're like you're cutting it in half, I think.
52.8.
52.8, blah 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 blah. Okay. And the problem says to the nearest thousandth. So help me out. Keep going. 52.8.
Do it again.
52.8.015.5.
01515 blah blah. So it says to the nearest thousandth in the instruction. So which number is in the thousandth place? The 1. So what are you going to round that to?
2.
2. I gave it away. So C is approximately, yeah, there, bird. Approximately that.
How we will get that without a calculator?
You won't.
We won't.
No.
So
Okay.
we have to.
Yes.
That's good. You have it in the text.
For that part,
Okay.
there will be 2 parts. One part no calculator, the other part use it all you want.
It's alright for one time. It's not
I already did it once. How do you feel about that kind of problem? Okay.
So, to take it back to the very beginning for 33, and you're doing 22 to the second power and then 48 to the second power, I was confused and was thinking M was like similar to X, so I was doing 22 X.
Oh.
X. But that's not the case then.
Yeah, hey guys, what does that M stand for? Meters, cool. So they didn't really, that's kind of evil on their part. They didn't really mean it to be variables.
Okay.
That would make this problem just a little bit worse than it should be.
Yeah.
Yeah,
Okay.
I agree with you. Okay. So, if I gave you a problem like this, which you never know, I might do. So,
A plus B plus C.
not quite.
I mean, square.
How will this equation get set up? Which side is the most important side?
C.
And which one is C? 7, I love it.
So we
7
know
is
we
C.
don't know A or B.
So B.
So you can call this one, if you want to, 11. Or B, who cares? You call that one B. Now how does your equation get set up there?
A plus 5.
Square.
A squared
Plus B squared.
plus B squared.
Plus 5 is 25.
Equals 7.
49.
You see the difference there?
Yeah.
On the problem we did earlier, we didn't know C.
What's the longest?
So I had one side that had nothing but numbers on it. Here, I don't know one of these legs. I don't know A in this case. I know C all by itself over there. Over here, I got A squared and 5 squared. So I'm going to have to solve it like I would any equation. So the first thing is to do is, like you guys, I heard some of you guys say, that's 25. 7 squared is
40
So move
minus
25.
24.
Square.
A equals 4.8.
Do it again.
8,9,8,9,7,9,4.
So if I round it to the thousands place, what would that be? 4.8. Round it to this place, what would you get?
9.
Because the next number's a 9, so you got to round it up. Right? So the whole rounding process does not care if you have a decimal, if you have a really big number. It doesn't care. It says, find a place you want to round to. Look at the next number. It's bigger than 5. 5 or bigger, so then I make this one go up. So it'll be about 4.899. Yes, ma'am.
When you do rounding, you have to start from the last number on the right.
So in this case, I want to round to the thousands place. So I find the thousands place, tenths, hundredths, thousands. I found it. And then I look to the one next to it to see what am I going to do with it.
Oh, so you don't have to check what the 7 is, if it's going to change the 9.
No, it's not dominoes. I like it. It's not, and that's a real easy mistake to make. If I had like 4.444449. Stay with me now, because this is a real good question. If I said round it to this place, well, if you start there, that's going to make that become a 5, which is going to make that become a 5, which is going to make that become a 5, that become a 5. You guys kind of see what I'm saying? But that's completely not the right thing to do. Completely. Is 4.44 business? Is it closer to 4? Well, where am I trying to round to? Closer to 4.4 or closer to 4.5 if I'm trying to round there? Yeah, it's closer to 4.4. It's not even halfway. Halfway in between these two would be 4.5. Yeah, where am I trying to go here?
Yeah.
4.45 would be halfway. In between 4.4 and 4.5. Right? What would 4.45 get rounded to in the tenths place?
4.5.
4.5. That would go up. But what would 4.449 go? It's going to go down because it's closer to 4.4. So you don't domino back. You don't start here. And do you see what I mean by domino? The 9 knocks the 4 into a 5. It knocks the 4 into a 5. No. You look directly next to where you want to go.
I have a cousin in calculus, and that's what he told me. And now I'm kind of like,
Email his teacher. Tell his teacher, look out for this guy. That's bad. And that's an example of something that can go unchecked for a long time, because rounding, you could think like that and you can get away with it for a long time because it won't get you wrong a lot of times. But that's completely wrong. Yeah. Okay. So don't make that big of a deal out of it. If I ask you to round this number to the tenths place, you find the tenths place, you look next to it, that's not 5, that's less than 5, so make this 4.4.
Right?
Done.
0. Or you don't use 0.
No, it's 4.
What about 9?
Yeah, I'm kind of with him on that. So I thought it was always like 40 or 50 or 45 or whatever.
So if I'm rounding it to the tenths place, what could happen to this number? What two things could happen to the number?
It's going to be the same.
It could either stay the same
Yeah.
or go up to 4.5, right? That's the two choices. So really what's going on with rounding is, which one am I closer to? Am I closer to 4.4 or am I closer to 4.5? And we can analyze the hell out of this if you want to. I'm completely prepared. How far away from 4.4 is this number? Oh boy. How do I determine how far away two things are from each other? What operation would I use to determine how far apart two things are? Subtraction. So what is 4.4444? Why did I have to do this? Minus 4.4. It's 0.044449. This is exciting, I know. Just try to contain it. And now I want to know how far away is that from 4.5. So what is 4.5 minus 4.444444? How many 4s are there? 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. Oh yeah. You know it. You asked for it. So just to cut to the chase, you would do this is what it would come out to be.
Way to overanalyze.
0
Yeah, I know.
minus 9?
Try it. Do it in your calculator. 4.5 minus 4.64 is 9. Do it in your calculator.
there's 6 zeros.
Yes.
When she asked the question that she thought the 4 would go to 40, was she talking about whole numbers instead of decimal?
I'm not sure. I'm getting there.
Yeah, it's correct.
Yeah.
Yes, correct.
Really? All right. I was hoping. Now, and I know this is way too far with this problem, but it's too bad. Because this is what we do when we round. This is exactly the idea behind rounding. If I want to go to this place, it can either be 4.4 or 4.5, and how do I tell? Well, which one is it closer to? And if we really overanalyze it, we actually do the subtraction, which is how I tell how far apart two things are. Which one of these is a shorter distance?
That one.
The first one, so it's closer to 4.4, so that's what I'm going to round it to, because that's what it's closer to, right? Now, what's the shortcut of all that crap? You look at this dude. If that dude is less than 5, from 0 to 4, you leave him alone. If that dude is a 5, you're going to take it up, because the 4.45 would be exactly in between these two. Because how far apart is 4.45 from 4.4? I like that. It's 0.05, right?
Yeah.
If I subtract these, then it's 0.05 away from that. So it's exactly halfway in between. So we just chose that as the part. That's where it starts going up to here. Okay, maybe. So that's way overanalyzing. That's why this part doesn't come into play at all. The shortcut is, look at this guy. Because if that was a 5 there, that's exactly halfway in between my choices. So if it's less than that, I go to the bottom choice, the lower choice. If it's that or more, I go up to the other choice. That's that shortcut we created instead of doing this every time, thank God. Right? So that's why this stuff down here doesn't matter. All that matters is right there.
What if that 4 that you circled is like a 9?
Then it would go to 4.5 because it's closer to 4.5.
It wouldn't go to 50 then. Well, yeah, I guess it would. Because it was.
Yeah, and again, remember when
dropped
you're
it to 0.
dealing with decimals, 4.4 is the same thing as 4.40. Same thing as 4.400. I mean, those are all the same number, right? Math says those are the same. Science says they have different meanings, but they're all the same number. They're all 4.4. Right? Science would say this tells me I'm more sure about what I see, but math says they're all the same freaking number. Maybe. Just to get you ready for your science courses. You'll already have heard that. All right, let me get rid of this thing. Okay, nice clean slate here. So don't make a ton of stuff out of rounding. And there were some rounding issues still. I still have people telling me that, if I say round this to the nearest 10, somebody just says the answer is 3. And where did they get a 3 from? If they say round this to the nearest 10.
Because 28 is close.
How do you round this to the nearest 10? Where's the tens place?
28.
The 1?
Not, be careful.
30.
Not tenths. Tens. So the 2 is in the tens place, right? 8 is in the ones. Tenths. Everything back here has got that list, right? Okay, maybe. So how would I round 28 to the nearest 10? What's the closest 10? 10, 20, 30 is 30. So where do you think this person got the 3? Well, they made 2 become 3, and they said everything else goes away, and that's not good. 28's not close to 3. 28 is in between 30 and 20. So of course it's going to take it up to 30, right? So you have to put a 0 in to maintain the place of this. If I do that, what place is that in? The ones. It's supposed to be in the tens place. Oh shit. So if you wanted to, you can put a bunch of zeros back here, as many as you want to, because it doesn't mess with the place. I don't need all those. But you can't just cut everything off. You can't do that. It suddenly makes it a whole different number. I have 498 people. That's about 5 coming. That's about 5. I can manage that. I'll make 5 burgers. That'll feed everybody. No, you need 500 freaking burgers. Come on, right? I mean, that's the idea. What's it close to? Okay.
So can I ask a question?
Yeah.
It's kind of along those lines. Where you had us write fraction and then the words and then the decimal. So in words it gave 9 and 213 thousandths.
Okay.
So I'm not understanding how you write that.
So let's do one like it, just to be fair.
Yeah, okay.
So let's do like, if I said in words 11 and 27 thousandths. Is that cool?
Yeah.
All right, pretend like you can read that. So 11 and 27 thousandths. So that's in words. Probably the easier way to start is what's that as a fraction, because that's basically how I would say the fraction. So what part of that is not really fractional?
11.
And what's the part that tells me where the decimal goes?
And.
I love it. So if anybody had more than one and in your word statement, you have more than one decimal in your number, that's a little freaky. Right? It's like, what? I'm going to pay you $2.8.7. What's that? So that's the whole part, 11. That tells me I have a fractional or a decimal piece. And of course, how to write 27 thousandths?
27 over 1,000.
I love it. So 11 and 27 thousandths. So sometimes it's easier to start with fractions because that's exactly how we would say it. But how do I do this as a decimal now?
11 point.
Yeah, 11 is the whole part. And point.
0 to 7.
I love it. Now here's how you do it.
Here's where I messed up.
That last number has to be in the thousand spot. And then let me show you real quick. How would you say this number? I love it. But be careful. 1,500. Or you could say 1,500. Because 1 is in the thousand spot and 5 is in the hundred spot. But what's the other way to say that? 1,500. 15 is in the hundred spot because its last number is in the hundred spot. It's all about what that last number is. So if I want to write this, that 7 has got to be in this spot. So I give myself the little hangman game, tenths, hundredths, thousandths, and I start writing backwards. There's my 27. What do I have to put there?
0.
To maintain the place. So that would be 27 thousandths because that's where the 7 is. It's in the thousandths spot. Cool.
I have another one.
Real quick. So this problem here, I can either say this is 1,500, right? It's 1,500. Generally, that's what that says. Or I can say 1,500. Now, we pretty much, now here, I'll show you. We always default to this when we have decimals, because it's a lot easier than the alternative way to say this. The alternative way to say this besides 27 thousandths is to say 2, what place is that in? Hundredths and 7 thousandths. That's the other way to say this. Just like we could say $1,500, right? And of course the and is being misused there, but we'll go with the mistake in English. Or I can say 207 thousandths. And that and really means add. Because what is 1,500? That's 1,000 plus 500, right? So what is 27 thousandths? That's 2 hundredths plus 7 thousandths. Now we are really digging way deeper than we have to. But it's good to kind of see why this stuff works the way it does. I mean, we use this number system all the time, but we really never look at it. In Math 120, we actually explore other ways it could have been. Like, what if we would have had 8 fingers? What would our number system look like? But we won't do that now. Because, maybe that's enough of that. Because if I add these together, what do I get? How do I add these together? Just to really finish out this deep analyzing. What's wrong with trying to add those together?
Well, we need a component.
Exactly. They're fractions. I don't care what they have in them. I know that they're fractions, and I can't add them unless they have the same denominator. That's 1,000. That's 100. Yeah, multiply this one by 10. And of course, what do I get? 27 thousandths, which is what that is. So that's why what I'm trying to get you there is the idea that that last number sets up what place the whole number is in. Do you see that? That 7 is in the thousandths place. So basically that 27 is in the thousandths place because that's exactly what would happen. So you put that last number in the place. So if I wanted to write 112 10 thousandths. So I got 112. Where's that 2 got to be? What place does that 2 have to be in?
10,000.
In the 10,000ths place, because that's the place that it's telling me to go, right? So I go tenths, hundredths, thousandths, 10,000ths. Put the 2 there. 1, 1,
0.
0. Now I know I'm in the right spot. Cool. Maybe. Some of you just have to go back and remember what place each one of these is, so you can count it out. Yeah.
This is going to be what's on the test on the 19th, right?
Oh yeah, this is part of it. Yeah. Yeah.
Just I have another one.
Yes.
Another test. 0.5 to 1 in words.
Oh, okay.
I don't know.
So just to make it fair, let's do one sort of like that.
No, well, we have one, but not this one.
So if I had 0.728. So I want to write that in words. Well, again, sometimes it's easier first to go to a fraction. What would that be as a fraction? What place is that in?
Thousands.
About tenths, hundreds, thousands, 11. So as a fraction, it would be.
728,000.
And of course, you say that as 728 thousandths. So that's exactly what you write. Now, what you want to be careful about is that I saw some people doing this they say 700 and 28 10 thousandths or whatever. What is it? Thousandths. What's wrong with that?
Why is it 700?
That's checkbook style.
No, it's not even that. On your checkbook, you put the and. You only put the and right before you put the fractional part, right? Because that's where the decimal goes. So this would actually be 700 and 28 thousandths. I love it. That's what that would mean. So you get rid of that. And I saw two people doing this, 728 thousandths. That's not good. What does that mean? 728 thousandths. That's better. 728 thousandths. Don't forget your fists, right? If you just put thousands, that's way wrong. That's 728,000. That's way big. You got to indicate that THS to mean it's small, little tiny thing with a lisp, right? Okay. Anything else from homework or quiz? Yeah.
6.2 to 54.
Oh yes, this is another one of those fractions inside a fraction. Doing all right? Yeah. You said 54, right?
Yep.
6.2.
709.
So we saw one like this earlier. In fact, it was even a little worse because I have more than this many fractions, right? I have one variable down there. But how do I start this off? I mean, what process takes over here?
Cross multiply.
Cross multiples. I love it. So you can take, how do I write that?
7 over 9.
I like it. Right? Just 7/9 times n. So what is that? I don't know, 7/9 times n. Right? That's beautiful. I don't know what the hell it is. Let me just write it down. 7/9 times n. And what do I get on the other side again? Good. Times 1/4. And now I do the work on the next step. So what happens on this side? Yeah, 4 goes into 8 twice. So I get
2 over 27.
2 over 27. I like it. Just maybe. It's a little bit better way to do this more directly. Remember what we do when we have a fraction out here? What would kill it completely?
9 over 7.
Yeah, multiply by the reciprocal.
Yeah, by 9. Just
Which is really, if I divide by 7/9, what's division by 7/9? Multiplication by 9. So I am dividing by 7/9. I'm just doing it in a very smart way. So let me not make another big-ass fraction with fractions in it. Let me just go ahead and go straight, multiply by the reciprocal. Die. And is left alone.
1, 3,
3.
1, 3, 2 over 6.
2 over
21.
21. Done. So whenever you have a fraction in front of your variable, the shortcut is to multiply by the reciprocal. Because how would you kill the 9? I would multiply by 9 to kill it. How would you kill the 7? I would divide by 7 to kill it. So if I just multiply by 9/7, it has both of those in it. That's why it ends up killing everything.
So this is a short.
I was stuck on that question.
It's a freaky looking question. And Judy, in case you're curious, you could do it the same way you did the earlier one. Right? You could simplify this, simplify that. That would work. Now, I wouldn't probably do it that way, to say honestly, but it would still work. Yeah. Anything else before we get into some new stuff? Okay. So we're going to get into chapter 7. And let me start off by asking you, if I said, let's see, I gave you 2 representations for like my history of grades I've given. I'm curious, but I've never actually looked at it. So here I'm going to give you straight up numbers, and here I'm going to give you percentages. All right, so you tell me which one you like better. So let's see. Say I had 480 A's, 912 B's, 605 C's, 215 D's, and 89 F's. Why not? Which way gives you more information? Which way makes it more immediate what's going on? So this way versus, let me try to make it roughly right. Let's see. I've gone over. That sucks. Let's see where I'm at. No, I'm exactly that. Shoot. Too bad for you, Jeff. Make everything smaller. I'm trying to make these work out a certain way. All right. That'll work out. Okay, roughly. Which way conveys the information better? So you can immediately tell the comparison between. The percentage just makes more sense to us. It's a completely human-made contraption, to tell you honestly, is what a percentage is. And really all it's saying is about half the grades were B's, right? But if you just tell me 912 got B's, that doesn't tell me damn thing. If you say just a little under half the people got B's, that tells you a lot. You kind of, our brains aren't set up to understand large numbers and how they compare to each other. So we created this idea of percentages to help us see how do they compare to each other. How we doing so far? Okay. So where do percentages come from? In fact, we're going to make that maybe a little bit better here towards the end. If there are 32 people in here, and how many of you guys have ever been to Europe? Anybody? All right, so 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay. And 7 people have gone to Europe. You guys with me so far? So, you should have a feel for this. Is it more or less than half the class?
Less.
Less.
Yes.
Is it more or less than a quarter of the class? That's where it starts getting close. Yeah, what's a fourth of 32?
8.
Yeah, no. Side note, sorry. Yes. 1/4 of 32 is 8. So a little side note. So it's close to a quarter of the people. So, but I want to know exactly what percentage. And does anybody know what 1/4 as a percentage would be?
25.
And why is that? Because 1/4 is equal to what out of 100?
25.
Yeah, it's 25 times 25. And that's really what a percentage is based on, is just out of 100. So have you ever heard, like, when somebody tried to explain to you the budget, and they say, okay, 8 billion goes here and 7 trillion goes there, and we're like, I can't get that. Again, it's the human brain can't think that big. So we say, okay, every dollar you pay, 3 cents goes. Now I'm like, okay, now I get it. And that's $1 is how many cents? 100 cents. So we're basically making percentages. The percentage is just an attempt to take everything down to out of 100. You kind of with me? So that's why if I can make any fraction become out of 100, I know exactly what percentage I'm at. In fact, that's half of half, right? That's half of half. Half would be 50%. Half of that would be 25%. And that's exactly what 1/4 is. If I cut a pie in half and a half again, I get 1/4. So how do I get exactly what percentage of people went to Europe? Well, how do I set up the ratio?
7 to 32.
Good. 7 people out of 30 total people went to Europe. Now what's 7 divided by 32? Somebody help me out.
0.21875.
Kind of with me? So that's cool. That's just dividing. And that's close to 25. It's close to a quarter. Now what? If I round this to the hundredths place, what is this?
22.
Yeah, 0.22. And what's that as a fraction? 22 over 100? Which would be what percent? 22%. I love it. So our guess here, a quarter of the people would be 8. But it was 1 less than that. So sure enough, it makes sense that it'd be a little bit less than a quarter, a little bit less than 25%. It's only 22% of the people in here went to Europe. You guys semi with me a little bit? There's a lot of different ideas I'm throwing you all at once. But some of this you should have seen in your everyday life or done before. I want to keep that there. I want to make it better. So I want to connect some ideas. There must be some connection between decimals and percentages. Right? There must be some quick way to make a decimal become a percentage. And there is. Well, let's first explore this connection between fractions and percentages, and then we'll talk about decimals and percentages. So like I said, if I start off with that, here's a really cool way to look at this. Yeah, I like that. It's a really cool way. The percent symbol is like the number 100 reorganized, because percent means out of 100. So when I say 25%, that means 25 out of 100. So when I say 7 out of 100, that means 7%. Right? So percentage is really just taking that over 100 out of the equation. So it just makes it into a number I can relate to better. If I say 0.0006 people went, no, give me a percentage. Don't give me that weird little decimal. So this is the same thing as 7%. So if I have a fraction that is not currently out of 100. So maybe I have something like, what you got, John? 5. Let's do 7 out of 50.
14%.
Yeah. If you can get it to be out of 100, it's easy. So how do you make this out of 100? You just multiply by 2. So you have to do the same thing to the top. 14 out of 100 is 14%. Cool. Okay, how are we doing so far? And really quick, if I only had 7 people out of 50 that passed my class, is that good or bad?
Bad.
That's bad, right? That's bad for me, it's bad for them, it's bad for everybody. So it should be a very low percentage of people that pass the class. That makes sense. 7 out of 50 is not a very big part. 7 is not a big part of 50. So really at the heart, percentage is all about what part of the whole is this. 7 is a very small part. It's exactly 14% of 50. That's what that really means when you get to this point. You start with the fraction, end up with the percentage, that's what it means. So if I add another one like 3 over 25.
Divide by 4.
12%.
Yep, make it 100 by multiplying by 4.
12.
12.
12%.
So 12%. 11. Yes, ma'am.
If you were using a calculator, you would divide the top number by the bottom number.
Exactly, 11. So exactly how you read it, 3 divided by 25. Because I see when I say do this long division, I always get somebody set it up like that because they say, well, 25 doesn't go into 3. But that's too bad. That's exactly the point here. This is supposed to be a small number, right? It's not supposed to go in evenly, so it's got to be 25 goes into 3. In your calculator, of course, you just do it directly, 3 divided by 25.
Times 100, right?
Yeah, and then we'll talk about that. We're not quite there yet. So now, let's talk about the connection between decimals and percentages. Oh, crap. Somebody's got this. So the beautiful thing about decimals is they're based off of 10 already. So this whole idea of percentages being out of 100 should jive directly with decimals. So take an example over here. 14 over 100, what does that look like as a decimal? Yep, 0.14. Hundredths place is right there. So 0.14, that would be 14 hundredths. And I know what that is as a percentage. So how does that relate to decimals? What's kind of the shortcut here? So let's do another one. If I had 7 out of 100, what is that as a decimal?
0.7.
Careful.
0.07.
0.07. 0.7 would be 7 tenths. I need 7 hundredths, so it's got to be over in the second place. And of course, I know what that percentage is already. 7%. So what's the pattern here? What do I keep doing with my decimal to make it from decimal to percent? What do I do with my decimal?
Moving it over.
Move it over. Twice. And it makes more sense the other way. I'll show you. If I have, let's say, 3%. That's 3 out of 100, which is 0.03. So really the shortcut is, when I'm going from percent to decimal, I move the decimal back twice. Now, that makes sense because percentage means divide by 100. And what happens to the decimal when I divide by 100? Moves back twice. It's smaller, right? So when I go the other way, I'm effectively multiplying by 100. So that's what you said earlier, to make that decimal move over twice the other way. So the whole thing here is I know percentage means out of 100. So I know that it's going to be based on moving that decimal twice because it's got the number 100 in it. So there's 2 zeros, and we know I'm going to move it twice. The thing that people forget sometimes is which way do I go? So it's a very simple thing. If you put the letter D for decimal and P for percentage in alphabetical order, so D, calm down. If I want to go from a decimal to a percent, I move the decimal that way. If I want to go from percent to decimal, I move it back the other way. So for example, if I had 0.0042, is that a percent or a decimal?
Decimal.
That's definitely a decimal because there's no percentage sign. So I'm in a decimal, which way do I want to move the decimal place? From D to, I go that way. You guys kind of with me? I'm trying to show you a shortcut. I know it's twice because it's out of 100. It's dealing with the number 100. That would be twice moving the decimal place. It's just which way do I go? In this case, I'm going to go that way. Once, twice. So what's it going to end up being? 0.42. That is a really small number. So it's not even 0.5%. That's why it came out so small. Right? But if I had, what do you got, Jeff? 1.28%. Which way do I want to move the decimal place? Yeah, from percent to decimal is back this way. So once, twice. There's some zeros out there. Yeah, 0.0128. So what would 100% be? As a decimal, yeah. If I want to go from percent to decimal, I move the decimal back this way. So once, twice, it's 1, which makes sense. 100% of something is one whole thing. I haven't cut it into any parts yet. So 1% of something is stupid small, right? I mean, that's not much of it. So it makes sense that it should be 0.01. It should be a small decimal.
So 200% would be more than a whole?
I love it. And of course, in real life, you can have numbers larger than 100%. Not, you get the old standard, I'm going to give 110%, which is all mental. But to have truly 110%, you can say, well, our profits increased by 110%. That would make sense. That would mean that it more than doubled. That's what that would mean. Does that make sense? You don't have to stop at 100%. It is very possible to have percentages bigger than 100. Because all it means is you've more than doubled something, right? So if something increases by 100%, let's think about this for a second. So if I have $10 one day, and it increased by 100%. Well, what's 100% of 10? 10. And if it increased by that much, it's going to go up to 20. So if I increase by exactly 100%, that actually means I doubled my money. So if I increase by 200%, that would mean I tripled my money, believe it or not. So forth. So that's what percentages bigger than 100 sometimes confuse students because you're like, how could it be? You could have 15 people and 17 of them do something? How the hell, where are those other 2 people? Well, in that case, it can't be more than 100%. But when you're talking about how much does something go up by, it totally can be more than 100%. Okay. So help me out here. Let's look back at this thing. Let's see how close I got doing this in my head. If I want to know what percentage of the grades I've given were A's, what would I need to do first? Like, for example, we did the problem here earlier. We had 7 people went to Europe, and I couldn't get the percentage unless I also knew that there were 32 people. I have to find the total. So how many total grades are represented here? Somebody help me out. Yes. 2301? Sounds good to me. If I don't hear anything different, okay, go.
Yeah, that's right.
All right. So these are more than likely wrong. That's just me trying to make some numbers up real quick. So how do I determine what the percentage was of A's? I'd first do, how many A's were there? 480 out of 2301. So what's 480 divided by 2301?
0.21 if you're rotating.
I like it. So yeah, take me to 2 decimal places like that. Sounds good. 0.21. Is that what you guys are getting?
Yes.
All right, cool. Which is what percent?
21%.
I love it. Move it once, twice over. That's 21%. I got pretty close. What's 912 out of 2301?
0.40 if you're rounding.
So about 40%. I was a little off there. Oh well, too bad. What's 605 divided by 2301?
26.
0.26? So 26%? So forth, right? You guys kind of see what I'm doing? Okay, cool. So earlier I was just trying to do it in my head, just trying to get it close, because we weren't to the point yet where I could just do this. So just to finish this out, 215 divided by 2301.
0.09.
So about what percent? Once, twice over? 9%. I love it. And then finally, 89 out of 2301.
0.04.
So about 4%. So I got pretty close on those. It'll give me a little leeway. But these mean a lot more to us as humans do than these pure numbers do. I can compare them much easier. I can see that almost twice as many people got a B than got an A. Much easier. Now here I can see it's almost twice. But over there I can see the actual cut of the pie. So another way to do this, you see this all the time, like a pie chart. Right? You see, so if I wanted to represent 40%, it's not half, it's a little less than half. So that might be 40%. That would be my B's. Right? We've all seen pie charts before. So for the A's, it would be a little less than a quarter. A quarter would be right here. So a little less than a quarter, maybe there. That would be my A's. And so forth. Now I just cut the pie up. So percentages are very visual for humans. We can see that very quickly. It's that part of the pie. It's that part of the pie. I can compare it much quicker. So let me give you a couple of problems to try here. Convert these to a percentage. So how do you do this first one here? What's nice about that first one?
Multiply by 5.
Good. You can make it out of 100 real easy. Multiply by 5, multiply by 5, so you get...
0.55.
No, it's just 55%.
Now, I like what you said there. What is 11 divided by 20?
0.55.
Yeah, so 11 divided by 20. If you do this in your calculator, 11 divided by 20 is 0.55. And how do you make that into a percentage? Times 100, or just move it over once, twice? Same answer, of course. It has to be the same answer. And then this guy, yeah, times 4 times 4.
0.16.
Or, yeah, 0.16, which still gets you to 16%. Hmm? And what about that guy? So it's a decimal currently, right? So if it's a decimal right now, which way do I have to go to get to a percentage?
Right.
So then you move it once, twice?
149%.
149%. And why is it not weird? 1 is 100%. 1.49 is bigger than 1. I expect my answer to be bigger than 100%. So that's not weird. And then this guy is really, really tiny. So I expect my answer to be kind of tiny. So it's a decimal right now, so I have to move it
Twice.
to the right. So to get 0.3%. All right. So then the kind of problem I can give to you right now is, what about this? I don't think that was a reaction, but it was interesting. Can you make the bottom become 100 easily?
Times the 12.5.
0.875.
If you don't happen to see something like that, so 8 goes into 7. Yeah, 8, 64, 67, 56, 45, 40, 0. So it's 0.875. So what is it as a percentage?
88.
If you round it, so if you take it once, twice, 87.5%. And then I'd have to tell you where to round. Normally, if I give you a fraction that turns into a decimal, it stops. I just want you to take it all the way out. Yeah. You guys with me? So I can tell some of you guys are bored. This is okay. The rest of you are maybe like, what the hell? All right, so go on the last thing here on this section. Yeah, I gotta be careful with what I say. Is how to take things, convert to a decimal. Get in there. So convert those to decimals. You should be relatively quick. If you get the idea. So I'm in a percentage right now. To get back to a decimal, I've got to move it back. So another way to say this is the percentage number is always going to be bigger than the decimal number. So right now this is 407, roughly percent, right? So if I take it to a decimal, I have to end up with a smaller number. Does that make sense?
Right.
So if you have trouble like me with left and right, then just remember, my percentage number has got to always be bigger than my decimal number would be. So you can just step back after you've done something and make sure that's true. Yeah, my decimal number is smaller. So here I'm going to move it. This is where people always screw up. I always get 29 because people say to themselves, man, that little dude is already small enough, but too damn bad. It says you have to take it back twice. So it's 0.0029. Is that cool? 0.29% of something is really small amount. So it shouldn't surprise me it's just a small decimal. And then 6.051%. Yeah, just move it once, twice. So 0.06051. Bless you. Is that cool? Okay, so there's the how it works and the why it works that way. Now, let me give you an example of something that's going to lead us into the next section. So I want to do the section 7 too. Let's say I make $10 an hour. Thankfully I don't. But let's say I do. And I get my paycheck and I notice that they cut my pay by 10%. Out of nowhere. Didn't say anything to me. I didn't do anything to anybody. Didn't hurt anybody. Didn't yell at anybody. So I go and I complain and like, oh, we're sorry, Mr. Waller. We'll increase your pay by 10%. Go away now. Right? So I start to walk away, but then I know math, so now I'm still pissed. It's not good. So why am I still angry?
Because you still only make $10?
No. I'm angrier than just the fact that I'm just making $10 in the first place. If they take 10% off, I'm now making less money. If they add 10% on, that's 10% of a smaller number. In fact, let's take a look at what happens here. So people always say, when I first say that, they say, okay, 10% and 10%. What's the big deal? But 10% of 10 is going to take me down to something, and then 10% of that is not going to take me all the way back up. So we have to figure out, how do I do percentages of something? So if I have a question, if I say, what is 10% of $10? I love it. Not $100. That'd be crazy. Because think about what makes sense here. 10% should be a small part of 10. So my answer can definitely not be bigger than 10. Right? So how do I do this mathematically? Because we can get the answer really quickly, some of us, but what if it was, what is 0.825% of 4,978? I can't just look at it. I want to know the math behind this. What's actually the operation that I'm doing? And for some reason, people are coming out of high school less and less knowing what this means. When the word of is involved with fractions or percentages, it means multiply. So 10% of 10, what is 10% as a decimal? How do I make that into a decimal? 0.1. Of times 10. And what's 0.1 times 10? 1. Another way to look at it is, what's 10% as a fraction? 10 over 100, which is 1/10, right? What's 1/10 of 10? 1. So that's why that of means multiply, because that's what it accomplishes. That operation does what it wants to do here. So when you have a fraction of something or a percentage of something, of means multiply. It used to be like that, and now less than half of my students know what of means. It drives me crazy. So if I notice that I make 10% less than I did before, how much money do I make now? Yeah, I was making $10 minus the 10%, and now I'm at $9. Now they increased my pay by 10%. So it's all about the base number. 10% is not the same as 10%. It all depends on what's the base number. What's it of? 10% of a billion is not the same thing as 10% of 2, right? Very different. It all depends on what that number is. So here, what's 10% there of $9? What's 10% as a decimal? 0.1. Of means multiply. 0.1 times 9? 0.9. I love it. So now they increased. I was making $9 now. They added on top of that 10%. So now I'm making $9.90. And you guys should know that dime adds up over time pretty quickly, right? I remember making my first job I made like $3.15 an hour or something. So I got like totally for real. It was awesome.
You could live off that?
Well, because back then, gas, for example, cost 80 cents a gallon. So it all averaged out. Now, of course,
He doesn't even seem old. Yes,
what's the matter?
it just goes, he doesn't even seem old. Like.
Oh. What do you mean?
But you just said it.
Oh. Oh, yeah. Oh, yeah.
You know, like,
I'm old.
Yeah.
Old enough for that. Yeah. Okay. So does that make sense? I mean, I like that. I like that sense of realization that I at least saw one person have. But the idea of a percentage doesn't mean the same thing as itself. It depends on what it's of, what the percentage is of. The really evil thing about this problem is, if they would have given me a 10% raise, what's 10% of $10? That's 1. So if they raised me, that would be 11. And then they give me a 10% cut. What's 10% of 11?
10.
That would be 0.1 times 11. Am I going too fast? 10% is 0.1. Of means times 11. So what's 0.1 times 11? 1.1. So they would take me from 11 minus 1.1 is that freaking 990 again. So even if they would have accidentally gave me a raise, and then they wrote to me saying, we just noticed we accidentally gave you a raise. We're going to cut your pay by 10% just so you even it out. No! You gave me a cut now. It's just like, it's really weird to me that the universe seems to be against us. No matter which way you do it, you end up below where you were before. Right, that's a side note.
So in order for you to have made the same amount of money, they would have had to increase it by 110?
I love it. The place we could try to go to now is to figure out if a 10% raise off of 9 just gets me back to 990, how big of a raise would I need to get back up to 10 full, right? You guys kind of with me? They cut my pay by 10%. They increased it by 10%. That only took me to 990. Well, what percentage should they have put there to take me back up to 10?
Simply
Do you guys understand the question?
11.
Maybe. I mean, it's got to be something a little bigger than 10%, but let's try to really find it out mathematically. So if I'm at $9 right now, and I want to be at $10, how big of an increase would that be? $1. Right. So I really want to know, one is what percent. Now real quick, they did 10% of 9, and they got me to 990. The question really is, what percent of 9 would get me to 10, right? So 1 is how much I need to get to add on top in money. Well, what is it in percentage? 1%, 1 out of 9 is what percent? Because it's all based on 9. What percent of 9 would get me up to $10? So $1 out of $9. What percentage is that?
1.
Tell me out. What's 1 divided by 9?
0.111.
Yeah, 0.1111 forever, right? So that's going to be 11 see, because you got to move the decimal over twice to make it a percentage, right? So it'll be 11.1 forever percent. So if they increased my pay by 11.1 forever percent, which I would help them out with, then I would be back up to $10. So 10% I knew was not enough. It only got me back up to $9.90. So I love that question. Well, what should it be here to get me back up to $10? I knew it was going to be a little bit bigger, so whoever said 11 was really close. And that kind of made sense to be just a little bit more than 10. But the math says, yeah, you're right, it's about 11. Maybe you guys are kind of with me. I mean, this is where you start just thinking, I want to be able to do this. I want to figure out this. What math do I need to do that? That's what people miss. People say, why do I need math? Well, you start thinking, well, what if I wanted to know this? How would math help me get there? Yeah.
Payroll.
Yeah, payroll. Yeah, and of course you have software that'll do all this for you. But humans, I hope to God we still understand the math well enough so the computers don't completely control us. You know, I make $2 an hour now. I guess it's okay because the computer said yeah. Yeah.
So the first step to get the percentage of your number is to convert that percentage to decimal?
Good. Because percentages are completely made up. And what I mean by that is the percentage symbol is hiding the out of 100. So if I want to do math with a percentage, I have to have a real number. Not a percentage, I have to have the decimal number. That's a real number, right? So if I said, so the next biggest mistake I get is if you put $1,000 into a 5% account. You guys with me? I don't know. I was for a long time without a savings account, so it feels really good to finally have a savings account again. So I don't know how many of you guys happen to have a savings account, but you have to understand, you look around, you see the percentages. How does a savings account work? So if I put $1,000 into a 5% account, so every year I'd be making 5% of however much money I put in there. The biggest mistake I see is somebody says, okay, 5% of 1,000. Oh yeah, that's 5 times 1,000. That's $5,000. And then they just turn that in. There you go. And I'm like, think for a second. Do you really think a bank is going to give you $5,000 in 1 year? I mean, this is picking the right stock. This is not a bank. A bank's not going to do that, right? 5% of 1,000 cannot be 5,000. It doesn't make any sense. So the mistake they made is they used this made-up number here. So really, I need to use what's 5% as a decimal?
0.05.
Yeah, 5% as a decimal. I have to move it once, twice back. So 0.05. So what's 0.05 times 1,000? Yeah.
No, $50.
$50. 50 smackers. 50 greenbacks.
That's a lot nowadays.
Yeah, dude. Of course, that's a lot nowadays too, right? That's the old saying, you got to have money to make money, right? You guys kind of
They to give you $5,000.
Huh? If only. Yeah.
Maybe probably don't need to.
But then you can ask, all right, if I have a 5% account, how much money would I have to put in to make $5,000?
50,000?
That's not what I just said. Is that what you just said?
That's what I just said.
Beautiful.
So
405.
50,000?
Somebody's thinking the same way I am. That's crazy.
50.
So this is how you do this. How could I say this in a way that would actually set up directly into an equation? And we've already kind of done this earlier. But 5% of...
1,000 is 50.
I love it.
50 times 5.
We know 0.5.
So do I know the $1,000 now?
Multiplied by X equal 5,000.
When it was 5% of 1,000, I knew exactly what to do. Now it's 5% of... I don't know, right? So 5% of what is $5,000, right? Because I know that 5% of 1,000 is 50. 5% of what is 5,000?
So 500.
So look, watch this. Here's the beautiful thing about, and again, I keep stressing the English to math translation. What's 5% in mathish?
0.05.
Good. 0.05. Math doesn't like percentages. It wants decimals. Of means times. What?
X.
I love it. Is
5,000.
equals.
5,000.
Oh, divide by number. Divide by.
Divide by, right?
Zero,
So
five.
see, if you could phrase a percentage problem like this, it translates directly into mathish, and then the math just eats it up, right? So what do you get? How do you solve this? Divide by 0.05.
Yep.
That's $100,000.
So x equals
100,000.
Yep.
So,
Rich people.
Now, just to step out of it for a second, remember, 5% of 1,000 was $50, right? So we just did 5% of something is 5,000. Well, how much more money do I want? Even better than that. How many times more money?
100.
Yeah, 100 times more money, right? 10 times than 50 would be 500. 100 times 50 is 5,000. I want 100 times as much money, which means how much money do I have to put in? 100 times as much. And what's 100 times 1,000? 100,000. So it only makes sense what we got. That, of course, is a shortcut. Now, the reason we did all this is because if the numbers aren't nice, then I want to have a procedure to go through that will actually work. Okay, so let me give you guys a couple to try on your own. A little more direct. So here, try these two. And you can totally use your calculators. Right.
So above. Somebody's gonna give you an answer later.